So welcome all of you for this session, programming FEA, finite element analysis, that is a bar element programming and spring element programming. We are not discussing about beam element, we'll discuss sometime later. So basically I think you people know what does that MATLAB programming means what is the way we can do the program in the MATLAB, because already we have gone through some of the subjects like numerical methods and kind of the subject, which gives a basic idea about MATLAB programming. And this particular program, this particular session is typically concentrated or typically highlights about how to do a FEA program using a MATLAB tools. So here when we are doing a programming, I will give a brief idea what is the way we need to think into the programming, because programming is nothing but a tool we have to use like a tool. It is not a bread and butter, but it is going to help us to do something. But first of all you should know what you want to do it. So that is what first you need to have an appropriate logic for it. What is my program logic? What kind of program I want to do it? That is what it is called as logic. In this logic we may be doing a logic in 3 stages. First stage is you are going to take some input from the user, or you may be going to give the input in the program kind of things. Second part of the logic is what are the processing you are going to do it using the inputs provided by user, or you may be providing a separate file for an input or kind of things. And then you are going to do the processing. Maybe you are doing looping, you are going to do 1, 2, 3, 4, maybe multiple n number of tasks into this. That is what in a second stage. And third stage, you want to see the results. That is what in a best last step, where you are going to collect the information, what is we done it and what are the results coming. Maybe you can take a simple example. I want to determine a deflection of this bar. So this is a bar, deflection you want to determine it. So here this force is applied, maybe a 50 Newton. Okay, diameter of this is, you can take a 10 mm something, and material property you can take a 2.1 into 10 raised to 5. Then what else we need it? So area we can calculate E. Okay, so you want to determine a deflection. This is what on a target. So this is my input. So what is the way we need to proceed? First of all, inputs are here it is in a material property, that is E. Then your diameter is my second input, and one more input we need it, that is what is the length of this entire bar, that is a LL, and what are the external force. These are the inputs we got it. So this input, once we got it, we need to put this input into this formula, that is D delta is equal to FL by how much AE or EA or whatever it may be. So this is typically tells in a deflection of the beam using a simple equation, that is a Hooke's law. We can go back to the Hooke's law. I will just tell you what is meant by Hooke's law. How can we derive this equation quite easily? So we know the stress, we know the strain, and we assume stress and strain. This is one axis strain, another axis stress. I assume the slope of this is nothing but my E value, that is Young's modulus, and this is going to pass through the zero line. That's what I can now fit this curve. Is stress is directly proportional to strain. I can say stress is equal to E, my slope, epsilon, plus as it is going to pass through the zero, I will write it here. Now I got a stress is equal to E into epsilon. And we know that stress is nothing but a force upon area and E into delta upon L, and if you bring all the delta on one side and the rest of the elements on this side, so you'll get this formula. So when you are going to give a gate exam or any kind of an exam, This type of most of the time you can't remember all the formulas, and engineer job is not to remember most of the things, but we need to just remember what is the basically fundamental logic behind it, and based on that, in most of the time we need to derive the formula on 11th basis when we are going to give an exam. So for that purpose I told you what is the way you can process it. Okay, so once I got this formula, so I know the f here, I have the L value in the input. I don't know A value. I can now determine A is equal to pi by 4 d raised to 4 d raised to square d square. So this is the area. This is what one task we completed. Then next task is put this delta is equal to FL by EA, and then determine this is what a processing we got. This is what a logic we got it. And what is the output you are going to look at it? You want to display the delta, that is my output. So this is what on a very simple program, and the same way here, maybe you're going to do on any complicated program also. You need to first of all identify what are my inputs first, then what are the logical steps through which I need to do all the mathematical calculations, or maybe some other logical calculations kind of things, and what exactly you want on a result. So that is what it is expected. So these are the 3 steps through which we can do on a program. So when we are doing in a program, so we need to first of all look out the basically I can tell you the programming means we are going to talk to the computer. So I can just now just draw one simple block diagram, and then we'll start in a programming for this. This is my CPU of the program, that is a PC, and I'm going to give some input instructions to this, and this CPU is going to process it, and it is going to create an output, and this output may be displayed on the screen or display, then maybe giving a printer output, maybe it is going to give an output on web or something like this. So you can have multiple outputs here. What are the inputs? I can have keys. I am going to press those keys, and then I am going to put up a mouse. I am going to move it, or I am going to pointing device, I can say. It is on a pointing device I am going to use it. So these are the inputs to the processor. And this processor is going to do some kind of calculations. Maybe it is going to use an AND, NAND, NOR. All these logics are mounted onto this, and it is going to process, and it is going to generate an output. So how it is going to do is, key means we know A to Z keys are there. 1 to 9 numbers, that is 0 to 9 numbers are there, and some other symbolic keys are there. So these are the keys are further converted into some voltage signal. That is once we are going to press it, it is going to generate some voltage signal through it, and this voltage signal is nothing but given to your CPU, and this CPU is now further processing and creating an output. This is what in a simple way we can say it. So another one, once it is generated on a voltage signal, if I press A, it has a certain meaning for it. So for that purpose, there is one more operating system or something. I can say it is an operating system. This operating system is a Windows operating system something. So this Windows operating system does, it will take a signal. So this voltage signal will be somewhere in between this now. This is I'll just wrap this so that will not be any confusion in later stage. Okay, so here it is going to generate a voltage signal after this OS command, and before this OS there is some that is a programming editor, I can say. This editor will generate a signal to the compiler, and there are 2 ways by which we can do the programming. One is compiler and another is an interpreter. I will tell you the difference between this. So what it does, once it is programming means we are going to create in a certain set of instructions. Like as I am going to teach you FEM, I first of all taught you about review of all the subjects, then bar element, then beam element, then I will now 1D problem I solved it, then 2D problem, then 3D problem, and then real life problem. These are the multiple tasks through which we are going to do it. So program is nothing but a sequence of the instructions which you want to get it done from the CPU. So this is maybe in a first statement, second statement, third statement, like this sequence is there, and that sequence is given to the compiler. What this compiler does, compiler will have his own library, and what this library says, as I am going to talk in the English, I have an entire dictionary of this entire English. So which word, what does that mean? So each and every command, maybe you are going to use a print as a command, maybe you are going to use a disp as a command, or maybe you are going to define x as a variable equal to as an assignment. All these are things are stored into this library. Okay, so this compiler will now, once you got this program, it will take this compiler, and this compiler will now go back to the library. And this library, what this library is going to do it, this library is going to help us to further give instructions to the operating system, and this operating system is giving a signal to the CPU, and then CPU is going to do the programming. This is what it is going to happen. So when we are doing in a programming, so basically it starts with, first of all, we need to do we are going to do a mathematical calculation. We need to first of all define certain constant. Okay, constants. Constant means a variable which doesn't change over the entire program. That is one thing. Next is a variable. Variable means this value. If I say x is equal to 5, so x is now, whenever I am going to use in the program, or I am going to call this x into my program, what is going to happen? This x is having a 5 value. That is what it is said. And if I am going to process with x equal to x into 2, this will become a 10, and now my value of the x is going to update it, and that's what this is now. It is going to, this value of the x is going to change whenever you are going to put up any kind of an operation onto this. So that is what it is called as a variable. Under this variable we can have an integer variable which don't have any decimal numbers. Then another one is float is another. Then character is, because we are dealing with all the characters A, B, C, D, character is one variable. Then another one is a string is one more variable. Likewise, you first of all, it is any program is built based on this first thing, variable, second thing, constant. Once we got this variable and constant, then there are certain processing commands. Commands means I am going to use some commands, like I want to operators. I can say it is in commands in this. I can have an operators. So this operator equal to means it is going to assign this value. Then I will have a division, plus, minus. These are the operators through which we are going to do the processing. That is what all these operators comes into this. After these operators, there are certain more commands like which can be done in different fashion, like that is what logical commands. Logic means I am going to put up an if else something. So this is what logic it is going to decide. Means if I value of x is equal to 5, then process this, or if it is less than 5, do this. So that kind of operations we can do it. That is what is an if else or switch. So these are the maybe multiple such logical statements will be there. Means it is done once, only once it is going to do it. So that's what it is called as a logical operator. Then next is a looping operator. In this looping, what we are doing, we may be doing the same kind of an activity multiple times. So I want to reduce the error with less than 1. So what I will do, I will now go on doing this activity multiple times. Like I can just take one simple example which we done it, that is Newton-Raphson method. So this is my f of x is a function, maybe something, maybe e raised to x minus x something. I want to determine root of it. Root means whenever this f of x becomes 0, I want to know what the value of x, and that is what I will say it is in a root of that particular function. So this is going to vary in this fashion. So this may be the value of my root, but I don't know. I may be going to start at this location. This is my x0. So I am going to take a tangent of it. I am going to determine x1 here. Then again go back, then again determine another tangent, then I am going to get an x2. Likewise, I am going to do this in multiple times. So that sort of an activity is called as a looping. Looping is possible by two ways. One is fixed number of fixed number of iterations or calculation, fixed number of time you want to do that activity. So for that purpose, we are going to use a for loop. Another one is while loop, means it is a conditional statement. I want to reduce the error. I want this error should be within this particular 5% of it. So I don't know how many number of iterations I have to do it. I may be going to start it somewhere here, maybe starting at this location. Maybe sometimes it is taking this, for this particular location it is taking 10 iterations, here it is going to take 5 iterations, maybe any kind of an iteration it takes it. But I want to calculate the error should be less than 5% error. So that is what in a logic. This is what in a conditional looping it is called. This is what in a conditional looping we are going to do it. So this is what in a basically I just given a review of it. What is the way you can do this? So whenever we are going to do any program, we are going to generate some variables. We are going to use an operators, that is the second stage. We are going to use in a logical statements. We may be using in a looping statement, and we are going to generate in a certain results. That is what the way we do in a programming. So this is all about typical MATLAB program. Now we look at when we are going to solve a FEA problem, how we are going to solve it in finite element method. FEA, what is the first step we are going to do is a discretization. So that is what in the first step you are going to do it. Second stage, you are going to do an assembly of it. So that is my second stage. And third stage, I am going to solve it. That is third stage. And fourth step is the results, or I can say it is a post-processing also. I am getting a displacement as an output, and I am going to determine a strain. Then we are going to determine a stress. Likewise, all the post-processing calculations will be done into the result section. So we'll take a simple example how to solve this. Okay, maybe we'll take a simple example like I'll take a bar and we'll look at it. This is my bar. I want to solve a problem for this. What is the way we can do? We can now apply the force onto this. I'm going to provide this is my actual model. This is what all the inputs I'm going to give. L, maybe area, and then E value, all this, and then F value, external force value. I'm going to do it. Once we done it, next step is I'm going to discretize this into the number of elements. So this is the way I can have a first element, then second element, then third element. I am going to give the node 1, 2, 3, 4 like this. So for each element, I have a sum matrix. This is one matrix I will get, then second matrix I got, third matrix I got it. So these are the equations I got for each nodes and each element like this. So that is what on a discretization step we done it. So once it is, I can now this elemental properties, like if I take any element, stiffness can be determined by EA 1 minus 1 minus 1 1. This is what basically a fixed type of a stiffness matrix. Only the change is going to happen if I am going to change the E value or A value. Means I can now generate n number of such stiffness matrix. Maybe sometimes I'm going to have only 2 elements, maybe 5 elements, maybe 1000 elements. For 1000 time I need not to put this. What I have to do, I have to generate certain function for this. So function is nothing but in a property of the programming, or I can say it is in a kind of a subroutine or something. What it does, it will take some inputs and it will process it and it will tell you the final output. So that is the way it works. Function is like in a mechanical engineering department for a principal. What it does, so whenever the principal calls and tells, I want an attendance of final year mechanical engineering for FEA class. So what he does, he will generate a signal to the HOD. HOD is nothing but a function. Function means he is going to now process the information. So HOD will not directly go to the class, but what he will do, he will go to the class teacher or course coordinator. So course coordinator will compile this entire information and he will go back to HOD. Means that is what the way it does. So now mechanical engineering department has created one function as a course coordinator. Principal has created in a department, mechanical department as in one course, one function. Likewise, it is multiple functions inside it can work it. Whenever we are dealing with a function means whenever we are going to do a repetitive kind of an activity, not like a looping kind of activity. Whenever I want to do a certain task and that task is you are going to repeat it. So that part is called as a function. In this function, whenever function means it is typically function will take some input. So that is what it is called as an input arguments. And output is nothing but an output argument. And this function have some more logic. Like just take an example of this, you want to do it. So I'll take an E and A as an input to my program. And I'm going to put into this stiffness matrix. I'm going to K is equal to, I'm going to determine EA into this matrix 1 minus 1 minus 1 or 1. And this is what the way we created in a matrix. And this matrix you are going to give as an output. So that is what the processing will be done first by using a function. So that same way we can have one function which will determine a stiffness of the element. So that is first thing. After the stiffness, so this I got multiple stiffness matrices 1, 2, 3, maybe 4, 5 something. I want to now assemble those stiffnesses. There is no logic behind it. How we are going to connect it? This 2 number node is a common to the element number 1 and element number 2. So what it does? So obviously I need to have this equation. And this equation should be added it. So that sort of activity will be done into the assembly of it. So that is what the second function I can generate it. So third function will be once I assemble it, I can now apply boundary conditions. So I can have a third function, maybe apply boundary condition. So that is my third function. And after applying boundary conditions, we are going to solve it by 2 ways. One is penalty way or maybe an elimination way. Any method you can use it. This elimination method or penalty method. So we can now have a separate function for this. So I can have one function here, then second function here, then third function. This third function is further generates 2 functions, that is a solution. I can have a solution as another function which will give me in 2 ways. One is a penalty approach, one is a elimination approach, and then it will solve it. Once it is solved, it is going to give me displacement values u1, u2, u3 kind of things. These displacement values are now I want to determine a strain. Now I can have a strain as one more function of this. So it will give these values into the strain matrix. It will determine strain values for each. Once I get the strain values, then I am going to multiply, or I am going to have one more matrix that is a function that is a stress, and it is going to tell me stresses in each element. So once I got the stresses, strains or something, there will be one function which will determine the reactions of it. What reactions at the base of it. So likewise, you can use a multiple function and you can try to solve it. So we'll now look at one simple case, that is what in a spring element. Do you have any questions now? Shubham, is there anyone? या साहजिक आहे, तुम्हाला प्रश्नच नसतात कधी, ह्याचंच मला चिंता येते. Anyway, so here we can just look at the problem that is in a spring element. In spring element, so this is what entire model of the spring element, entire model of your problem to be solved. And here we need to given another k value is given, then p value is given, then k is given, so we need not to worry about EA, we don't need it. In this case, this is nothing but in a complicated picture, you can see it. So for that purpose, you can now, what is to be done, global stiffness matrix of the entire system is to be determined. Displacement of the nodes 2, 3, 4, 5, that is a 3 number node, 4 number node and 5 number node is to be determined. Reactions at 1 and 2 is to be determined. And forces in each spring also we need to determine. These are the output you are expecting. This is what my output I am going to expect. And here it is my input. Along with this input, so this entire picture is another input to us. So now we need to process it. Processing means, first of all, you are discretizing. Means you are going to define this in numbers, not in pictures now. Because computer can't understand pictures, it can understand only numbers and logics. So we'll take a sum function, we'll create a sum function. Okay, so what is that function? Function means it will take some input and it will process it. So this is what the first function we created. I will directly go to the MATLAB, that will be better. So first of all, whenever you are going to do is in a programming, keep all the program at a particular folder only, so that it will be easy to find whenever you need it. So I will say it is in a FEA class as a folder name, and then I am going to create a one function, means I have to start in a new script file. Okay, whenever you are going to start in a new script file, okay, so I am going to write in a function as in a name of it. So this is what in a way you can write in a script file for in a function. Whenever I write in a function, means it is going to define this as in a file can be used for multiple times, or it will be in a particular task. So what is exactly output you are looking for it? I am going to K as in a stiffness matrix, I am going to look at it. That is what an output I wanted. Equal to, who is going to do it? That is a spring element, I will say it is spring element as a name for it. And what is the input you are going to give it? K as an input. So here I am going to have a capital K as an output and input as an individual stiffness of the spring. So this is what in a way you can write as a function. So now, but when you are going to write in a function, so one thing is that, so here y is my output, maybe I can keep in any capital way, and this is my name of the function, and this is my input argument for it. So here we are not saved it, so I will now write in a function defines. This is what this is what the statement I am going to put it. So this statement is going to help whenever we are going to use any kind of a program in later stage. Function defines spring stiffness matrix, spring stiffness matrix, and we can now write capital K is equal to, because you want a K as an output, you can define the matrix as a K minus K, then second row minus K, and then K, and complete this matrix. So this is what you want to do it, because this you want to do it multiple times. This is only one single statement, but when you are using in a same program or somewhere in program, so it finds difficult. So in that's the reason we need to write in a function for it. Once you written all the function, you can save it as same the name which you have written it here, spring element. The same name it will automatically take. Don't disturb it, take it as it is and save this. So once you save this, so now you can just come back to your MATLAB. Okay, I may be defining k is equal to 120 something, 120, and I want to bring this, I'm going to give this input to my element, spring element, and I'm going to give k as an input. So it is going to create a matrix for it. So this is what the way first we created in a elemental stiffness matrix. That is one thing we done it. Okay, and once we done this elemental matrix, so we can now create multiple elements for this. Means I can now go back to one more script file where I can go on writing. I will now write here. This program is problem number 1. Okay, determining deflection of the nodal points in the model. I can write it. So here you can provide an input. I'll write directly input, and now I'll write an input as an stiffnesses of each element. Each element. I'll write a k as an 1 stiffness, that is I'll write in a 120 as an 1 single stiffness. Next stage is to formulate elemental matrices, elemental stiffness matrices. Okay. So in this I can have how many elements we need to define it? Altogether we need to define one element, then second element, third element, fourth element, fifth element, sixth element. So I can have a k value, k first element, k1 I will say, which is equal to, I can bring that elemental spring element, k. Okay, the same, I think same function I'm going to use it. So I can have a k1, then same way I can write k2, then k3, then k4, then 5, and altogether last 6. So now I can give the name for number. I can change here so that it will be differentiated. 3, then 4, and then 5. So this way we created. We'll just run once and we'll see it. So what does the output it is going to give it? Okay. Then I will say it is in a problem. I'll give the name as in a problem 1 as in a file name. So when you are going to run this program, so how it is first of all creating an only stiffness matrices. You just look at it. It has created 6. 1, 2, 2, 2 times it has happened. This is 3, then this is 4, and this is 5, and this is my 6. So altogether I got 6 stiffness matrices. So you can just look at the 6 stiffness matrices. But these all displays are there. I don't want such displays all the time. That's what I can now use in one command here, that is clear all and CLC. CLC will clear the screen, and clear all means it is whatever the variable you are going to create it will be deleted so that it will not get interfere into your program. If you have created in K1 as in one variable in previous program and you are using, and somewhere you missed to define it, it will take previous program and it will mess up it. To avoid this, you need to do this. Okay. Once we done this, so what is the next task? So next task is to now assemble these elemental matrices. Means what is the way it is going to assemble it? Now I can tell you what is the way we are going to assemble it. So I can say here connectivity table I can create it. What does that connectivity table? Connectivity table means element number and node numbers. I can have this. And element number 1 is connected with the 1, I will now give the numbers for this. This is 1 and 3 is connected. Okay, I'll write 1 and 3. So element number, this is element number 1. So element number 2 will be defined here. So element number 2 is 3, 4. 3, I can now take a 3 element, third number element is here, and it is connected between 3 and this is 5. 3 and 5. 4 number, this is my fourth number element. So it is 3 and again 5. 3 and 5. Fifth number, this. I can give a 1. Fifth number, that is 5 and 4. That is 5 and 4. And sixth number, last element is 4 and 2. 4 and 2. Likewise, I can now create a connectivity. When we are going to assemble this, okay, so what we are going to do it, how many number of degrees of freedom for this? Altogether, how many number of nodes are in this? Number of nodes in this is, total number of nodes are 5. Maximum number is 5. Okay, so I can have now total DOF of my model becomes 5. Okay, now I can create an entire matrix for it, 5 by 5 matrix, and I am going to substitute matrices, that is the elemental matrices, into this big matrix. So that is what we want to do it. So that is the way it is done it here. I am going to define in a bigger matrix. So this is what the way you are going to do it. So this is 1, 2, 3, and 4. This is maybe a 5 for our problem, and same way I can have a 5 by 5 bigger matrix. Once we done that bigger matrix, what is to be done? So in this program, what is to be done? When you are going to connect this, so you need to now create a function which will take in a stiffness matrix as an input, and it will process and keep into this big matrix. Means I want to substitute this small matrices of spring elements into a bigger matrix upon a global stiffness matrix. So that is what you want to do it. So for that purpose, what I need is, I need in a connectivity table. So these are the connectivity tables which will tell me information about it. So that is what a connectivity table will help us. So what I need is, I will now first of all define a stiffness matrix. Okay, thus I will now define all the elements of the global stiffness matrix equal to 0. That's what this function is going to use. So this function is inbuilt into the MATLAB, and this function determines a stiffness matrix by 6 by 6 with all the elements into it equal to 0. So now this K is nothing but my original stiffness matrix, which is all the elements are zeros. All zeros are there. So these zeros I should be replaced with a K-bins. Where to replace? I want node number 1 and node number 3. So this is what the first element will be replaced. So how it is done? So this is nothing but a function. It does this activity. Mandalavari. What it does, it is going to take this function. This is what 4 inputs you are taking. So that is a bigger K matrix and smaller K values. In this, so this Kii and this Kii will be substituted at 1, 1. Kij will be 1, 2, 2, 1, 2, 2. And these are nothing but 1 and 3 numbers. I will represent 1 and J will represent 3. So if you look into this, when I am going to assemble this 1, 3 first element, what it does, it will take a matrix. This is 1, 2, 3, 4, 5 and 6. This is 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Sorry, what I will do, I will just erase this and I will. I will now have sorry. In this case we are having a one element 2 3 4 5 and 6. So this is 1 2 3 4 5 and this is my 6. So ultimately node 1 and node 3 is to be filled out, means this element will come, this element will come, and this also will come, and this also will come. So these elements, that is one will element will be sitting at this particular location. This is one thing. So 1 2 will be sitting at this location. Then 2 1 is going to sit into this location because it is 1 3, because third number node is connected. Then to the same way 2 2 is going to sit at this location. That is what the way we need to do it. So similar fashion you can look at the 3 4. So what is the third number? 1 2, this is 3 and this is my 4. So simply I can now, this is 1 is going to sit at this location, second, third and 4. That is simply, it will get it added into this. That's what here addition symbol is used. Here it is a addition is used. So now we'll write a function for a program for an assembly purpose. Now I'll create one more function. I can start one function file. Function, I can say k as in a capital output, and spring assembly is my name of the function. I need in a capital K, I need in a small k, I need in a I need in a j as in variables for this. Okay, so this program, this is does an assembly of spring elements. Okay, now I can write in a capital K, and that is I, that is the first thing. I will say it is ij is equal to this. So you can just look at this program, it is already written out here. We'll just ij, and all these four combinations we need to do it. So if I say I need to have k I plus small k, which is 1 1. So this is one thing we done it. Okay, so similarly I can now repeat it for other locations. Here it is a ij, I will change. So as I am going to change ij, here also will become a j. Here I am going to change here 1 2. Is it clear? The similar fashion I can now write one more statement. I can have a j I. So I am going to change here j. Then I am going to change here 2. That's it. Okay. Then next I am going to have a jj. Both the things I need to change it. J. Here I will now j. Here also it will have a j, and this also will have a j, and then I will have a 2 here also, and here it is a 2. So this is what the way it is going to do in assembly, and updating the global matrix into the assembled matrix. Now I can save that file as it is. Now I can just check it whether it does or not. Okay, so we'll just look at spring k. We know it, k, that is k when I will take spring assembly. I will take a k. I will first of all I need to define k is equal to zeros 6 by 6. Okay, then I will have a capital K is equal to spring assembly. Then I will take a capital K, then small k, then it is automatically it is going to tell me. So I want to have 1 2 as in 2 elements. 2, I will now say it is connected to 1 and 2. So you can just look at. So it is going to tell me out of bound. Okay, somewhere it is k is equal to 1, ij 1 2 1 2 1 2. Should not happen. ij capital somewhere. Okay, actually we'll say it, maybe some. Okay, so here it is a k is stiffness matrix. K is a single number, so I will just show you what is it, why it is showing this error. So k is another single number. Actually we want a stiffness matrix, that is 1 2. So that's the reason it is going to give me this error. Understand? So I'll now change this k to the k, then you can just look at it. It is going to sit it here. So if I replace this with some other number, maybe 1 and 3, you can just look at it. So it will go and add it. So before that I need to make it k00, and then I need to run it 1 3. It is going to substitute 1 1 1 3 1 3 like this. So if I am going to put it 3 5 something, it is going to put into third row and fifth column. So then here it is added into this, and then this is fifth 3 and this is fifth. That is what it does. So this is what the way you can do the assembly of it. So now we'll come back to our main program, so where we have defined all the stiffness matrices. Next step is the assembly of the program. So how we are going to do the assembly? The same, that function we already done it. So we have to define first k is equal to zeros or something. K is equal to zeros. I'll say it is in a 6 5 by 5. Also 5 by 5, because altogether how many elements are there, how many nodes are there in the problem? Altogether we have 5 number of nodes. That's what it is wrongly written. It is 6 by 6 should not be there. It is 5 by 5. Okay. So then I will now use this command, this particular So I will now look into the elemental connectivity table and go on doing it. So don't look at the program which is created by somebody else. You create your own program. That will help you in many places, because so logic starts with your own thought process, not with others' thought process. Okay. So element number 1 key even, and here it is a 1 and 3. You can just write it. Then similarly I can have I'll now update this with second element, that is I will say it is in a k2, and here it is in a 3 and 4. 3 and this is my 4. Then similarly I can have one more k3, that is 3 and 5. 3 and 5. Then one more, that is again 3 and 5. This is 3 and 5. Here it is a fourth number. Then again I can have one more element, that is a fifth number of element. So connectivity is 5 and it will take automatically 4. Don't worry about it. If you are going to change the sequence, that doesn't matter. And then last element, that is a sixth element, and 4 and then 2. So that is what the way we can go on assembling it, and we can do it. So we can just run it and we'll just look at it how it is to be executed. I need more 5 minutes into this. Okay. So I'll now run this program. You will come to know how the 6 elements have assembled it. Okay. So first element 1 3, second element 3 4, third element 3 5, fourth element 3 4, the 3 5 again. Okay. Then 4 5 4, and then 5, that is a 5 4. That is what last element, that is 6 elements are now compiled. Once we done this entire compilation, so next task is to, now we created an assembly created, and this is what the assembly matrix we created. Now we need to apply the boundary conditions. What are the boundary conditions? So you can just look into the back to the model. In this model you can just look at here. This is node number 1 is fixed, node number 3 is fixed, According to penalty approach, what is to be done? I need to remove node number 1, that is a row number 1 and column number 1 for u1, and column number 2 and column number. So that is what I given a numbering, that sort 1 and 2 I can carry directly remove it. So if I remove this 1 and 2, left is 3 like this. Ultimately I'm going to solve this much matrix only. So that is what I want to remove, this part of this entire program. This is to be removed, so this is to be removed. Only this is to be solved, this much part is to be solved. So that is 3 to 5. This is third number, 1, 2, 3. 3. That's what I'm going to use. This is nothing but a technique by which we can apply the boundary conditions. I want to remove it. That's what I can eliminate it. So that is 3s to 5, 3s to 5. And I'm going to apply the force at this fifth, which are the node. So I can now create a force matrix, that is 20. Okay. Now we'll apply the boundary conditions and we'll solve it. Now just go to the again script program. In this script program I can have apply boundary conditions. U1, here it is U1 is 0, then U2 is 0, and F5 is equal to 20 something. Okay, so for that purpose I will now use a K, then I will give the some different name for it. We can just I will take a K I will just write K is equal to K. I am going to extract it, that matrix 3 to 5, because that matrix we most of the time we may be needing in later stage. So we will now replace, we will not replace that. So this is one way we done it. Force matrix I can have first element 0, second element 0, and third element 20. So this is the way we applied forcing boundary conditions. Once we done the forcing boundary conditions, obviously you need to solve it, and that is what you can do it, and that is what you can get in displacement results. So next step is I can have solution. In this solution step, I can now U as a displacement I want. KK is my stiffness matrix. I will now use a backslash command which will solve this. This is what the way you can use our simultaneous equations, and then it will display the output. So we'll now look at these. This U is going to give me 3 outputs, 3 values, and which is nothing but displacement of the 3 nodes. So it is going to give me the displacement of node number 3, 4, and 5. So this is what the way you can do programming for determining the displacement of the matrices. This is what the way you can do any kind of an assembly. You can again bring it more complicated in later stage also. Anyway, this is for today's session, and we can continue such programming discussion in next sessions also. So if you have any questions, you can ask the questions.